that's us. I haven't. We haven't gone actually. 15 minutes. We're working on this stuff. I have to wait. I think you should use separation until really difficult.
There's a chair over here.
We're going to do a demo of one of the applications we're using at the moment.
I just give the laptop a tap. I really don't power up first.
Yeah,
that was the start.
Okay.
Alright, so just going to give a quick talk on Zope Object Database. This is the storage component for Zope, which is, I presume most of you have heard, which is big web application framework. And I'm just going to show you a few examples of how to use this database with just in any Python application, because a lot of the examples are 15-20 lines long, so hopefully we can follow them and learn something about it. What is it? It's Python, persistent Python object store database. But it differs from it, and it differs from like any standard database that I've used before, like rational database, relational database, or in that there's no SQL statement, there's no layer or querying layer, because everything's done through Python. So basically the database, what it does is stores Python objects, and that's it. And well, it's not, there's other things it can store as well, but we'll go into that later. But primarily it's used to just store Python objects. So any querying of the objects that you need to do, we just use Python. Indexing, there's best examples of that are the Zope tree, since ZC catalog, but I don't think we're going to go into that today. I just added this last statement because in order to store the data, like, it needs to serialize the data into basically a string, and basically it just uses the standard Python pickle object, or Python pickle module from the Python distribution, which is available in any install. So if anyone's actually used it before, they're probably familiar with 90% of what this thing does. And sorry, no worries. If anyone has any questions, just stop me and ask. Installation, which will hopefully be finished by now, is just easy to install, and there's a URL there. Let's stick it up on python.ie and play around with it later. You can copy it from there. Alright, so I was just going to basically, that was a really brief introduction of what it was, and so I was just going to go straight into code just to see each line of it is, like I only said they're like only 20 lines long, so it shouldn't be too bad. So basically, this is a simple contacts application. It's a really simple contacts application, and basically what it's made up of is a collection, and which just stores contact objects. So basically, create a contact object, or contact object, which just contains first name, last name, telephone number, email address, and aliases, and we have a collection that just stores all of those. So, so basically, it's just any standard Python object. And basically here I've extended it and just said that it extends the persistent class, which I'll go into a bit later. Basically all this does says if you change any of these, it will tell the ZODB that this object's changed and it will automatically save it. So then basically for the collection, which would be another persistent object to just store it's persistent again, and we just have some code in there just to add the contact, index it, because as I said previously, all the querying and indexing has to be done in Python, so if you don't use setc.catalog or any of the other indexing tools, you have to basically write it yourself. No way around that. And then finally just a method to search. And so that's basically our application. It's pretty simple. And I have this script here, add contacts, which I'll go through in a bit more detail here. And this is basically what it's going to do is set up the database, which is just a file, and open it and basically add, I think, 3 or 4 contacts into the collection and then exit and just print out each contact as we go along. So a few import statements at the top. The first one is file storage, and this class is responsible for actually doing the serialization, which I said before, using a pickle object. It's responsible for writing the data to the files, to the underlying operating system, file system, and that's all it does. It's pretty, which is a lot actually. And then the second one is from ZODB. This is the database object, and basically what it does, when we initialize this, we pass in the file storage object, and it basically manages all the connections that we can open up to the database, and it will keep them all separate, and so if we modify something in one, it doesn't leak into another connection or anything like that. And import transaction, which is the transaction, basically it's a 2-phase commit transaction module for the ZODB. Basically, in order to store any of your data, you must call transaction.commit, or else when the program exits, it's just all your data is just going to disappear. And then this is our contacts that we kind of showed you. So I just have a print contacts just so you can see what data we have. So here, this is going to be the first, in our main method, this is going to be our first method we're going to use, which is basically open up the database. And so here we're basically passing in a file name. So we're going to say storage is equal to file storage stored in this file, and that's it. So then we have storage on, then we initialize our database, and then we just return it. That's all that method's going to do. So we go down to our main method. So there we're just opening, we're just going to call it in the var directory data.s. So we open up our database. This, if you have multiple connections, this kind of comes in, especially if you, but it's just probably good practice, like some of the things, just calling it just to begin the transaction. So then we basically, on our database object, we're just going to open up a connection and call it initDB, which will create our collection.
Can I ask a quick question?
Yeah.
At this stage, you specify a file name.
Yeah.
Is there a file name per table or other relations in one file?
No, it's just one file. And so basically what it's going to do is persist your, or serialize your object, and basically it's basically like a log file, so it's just going to write the serialized data to the log file, some header information as well, and then basically next time you make a modification, whatever changed, that's going to be written after it.
Okay, so the indexes are parameter in the DB object.
Yeah, no, that's what I'm saying. Like the index all has to be written in Python. So unless you use pretty much something from the Zope project, you're writing your own indexing. Like you could, like it is possible to use like another type of database just to do the indexing, and you just manage all the data, which is something we've been thinking about doing like for document management systems. So we'd use the ZODB to store like documents, contact information, and then you'd have a relation database to actually index all the data. So you can.
Although in a lot of cases, I mean, an index can be as simple as a list or a mapping, which you just do a Python operation. You just search for a key and you get a list of objects, a list of objects back, references back. Because it's persisting all the objects, it keeps all the references. So just create a dict of mapping your index into your actual results, and that was it. So you can get away with a lot of very simple indexing just with normal Python dictionaries and mapping.
That's my indexing method there, which is simple. 4 lines for basically keep a list of first names and list of all the IDs of the objects then after that. So that's it. That works.
How about manual usage if you have millions of records and you return a list of objects?
It's pretty good.
Can it return iterators?
It actually returns, what happens when you get objects out of ZODB is you get ghosted objects. So they're references that haven't been, I think they use the term materialized yet.
Yeah.
So until you access the objects, they're just lazily accessed.
Okay, but
say,
iterator,
if you have, let's say you have millions of objects, what you do is you need a container for them. And there's things, the B-trees module, and basically what it does, it splits up the data into sections, and it then stores each section as a different object. So then basically if you search, you can search within, if your search is only within certain sections, it's manageable.
And to answer your other question, yeah, it gives you iterators back when you do a lot of the basic queries. But one thing you have to be careful with the B-tree objects is they're a little, they can be a little bit fidgety at times. So you have to be careful that certain things that if you do something, it'll change under your feet while you're iterating over it. So it's usually safer to get a list of keys out of it and iterate over that, turn that into a list and iterate over the keys, pulling the objects out of the B tree as you go along.
Like one of the things we've probably noticed, it's actually very easy to write write applications using ZODB, a lot easier than like a relational database where you have to set up your table and you can't change it. You're going to have to think about it and change it. But in this I'll show you later, like with some more examples, that it's really easy to change objects.
What about parallel access and threading? Because ZODB is, first it was a part of Zope application server. And when you are, but now it was extracted from Zope, and now it's an external library, which can be used by scripts.
Generally, for threading, you'd have like just one connection.
Because you are using a file, so it's not locked.
That's what.
The other thing as well then is ZO. That's if you need.
Well, that's different from threading. That's client server database.
But then that's the next step up. Is that if you need multiple clients, like multiple separate processes accessing the same ZODB, the best way is to use ZO, which I use in my work and it works really well.
Well, like Zope's a threaded application, so there's no problem using it, because that's what we were just top. You had the ZODB.db object.
No, but it's interesting that you can use this library. Yes, an independent library. For any framework or any.
That's very nice. So I'll just fix the screen so it doesn't pick anything off.
Did you compare it with relational databases like PostgreSQL about the speed and memory usage?
Relational databases are going to be quicker, but this guy, like for development, it's a lot quicker. It's kind of. Like
it depends
It
depends what you're doing though.
It depends what you do.
If you've got an object mapper, ZODB will beat it hands down, because all it has to do is pick all the objects straight out. An object mapper has to query, pull the SQL, and then translate that into an Python object. So like for tree structures, stuff I do in my work, it beats relational databases hands down. But if you need to do an indexed query, then you typically want to use some external mechanism, because that will beat it. So it depends what you're doing.
Yeah. Okay. So basically, a ZODB basically sets up a collection if it doesn't exist. Because since it's persistent, first time we run this will just create a collection with persistent data. Otherwise, we just get it out of the database. The only funny thing about this is this root thing. I'm not too sure why, but with the connection, you just have to say "get me the root," which basically is just a dictionary, and you can just access it like any dictionary. And your data just, when you do transaction commit, it just gets written to the file. I might as well try and run this on this machine. It works on mine.
Let's make sure we have a var directory.
Yeah. Okay, so basically when you run it, it basically adds these three contacts, we all work here, to the database and commits, and each time through it just prints out the first name and last name. Let's see. So when I run it, the first time I run it, you get the ID for the collection is just a number that keeps going up and up, and basically each time you add a contact, it just goes up one and prints it out. So if we run it again the second time, we get 4, 5, 6, and each time I keep running this, it's going to go up by one more, or one set of 3 more. And if we look in the var directory, we see that when we initialize the database, we said, where is it? Or somewhere in it. It was you passed in the var/data.fs file, and basically if we look in here, we have data.fs. This contains all the data, and this, like if you run an application this and you're thinking about backing it up, this is the only file you're interested in. That just contains all the data. The datafs.index, what this is, it's for each object that gets persisted into this file, it's just a mapping from the object ID, what the database knows is the object ID, not my application, and to the position in this file where that object starts. So basically when you're loading the object up, we'll look up the object ID in the index, find it, or find the file position, then read in the data and unpick with it. Temp directory is just each time you do a commit, written to the temp directory first, so nothing there. And if this file gets deleted, it's just next time you restart the application, you just get regenerated. So just a big database can take a while, but you're not losing anything.
For 1 gigabyte data.fs with about 500,000 objects in, no more, 2 million objects in it, it takes about 30 seconds to a minute to regenerate the index. Yeah. So you're not taking a huge hit by deleting that.
But you haven't lost any data, but it's just wasting a minute.
This database, I heard it started off in Zope, but now it's actually separate, so you can
but the Zope guys did, when they were developing it, they just split up the code as in good software development practice, so they had everything got to do with the storage, transaction, what other parts of the database connections and all that was just developed as a kind of side module, and so now you can.
So it's possible to use this completely outside of the Zope context.
Yeah, like
I use it in a twisted application. And there's no Zope involved. So,
so that's how we installed it. He didn't have the version that we needed for some of the later stuff. So basically, you're just getting from Zope.org the 3 Alpha 1 revision, and basically it's going to download some dependencies. There's a handful of dependencies, I think 3 or 4, but that's it. Right. I think that was adding stuff to the database anyway. So let's move
Just out of interest, are they? I'm not familiar with Pickle, but are there any versioning, like in Java's serial version? Are these issues involved with persisting objects like that? If you're using a later version of a class, is there any problem deserializing anything later?
No, I've never run into problems.
Depends. You can do. Obviously, if you radically change the class, when it tries to deserialize, and you can't map the properties anymore, it'll fall over. But
there'll be no issue between the serialized data. Like if you serialize something today, and in 2 years' time, I'm pretty sure you're going because there's a version number associated with that.
It's only a problem if you change some code that references properties. But usually, there's a couple of things. There's a couple of hooks you can put into where you can put sort of code which can spot which version of the object's coming out and adjust it accordingly. Okay. So generally, it's not. I had an issue with it once, and I wrote a script to fix it in my database in about 10 minutes.
But basically, it's up to you to keep your objects you want to persist
like
more or less stable. And then
but generally, you can add methods as much as you want, as long as the attributes don't change under its feet, it's fine.
Yes, it's all about the data. Because remember, in the contacts you had first name, last name. If you add another attribution, then you create a few objects. It's all the old ones are not going to have this new attribution. So if you try to access that, you're just going to get an attribute error. Standard attribute error.
Because in Java there are guidelines as well, like what changes are forward or backward compatible. So for example, if you were to remove an attribute in future, then it would just skip over it and ignore it when reading it, and obviously won't be able to write it, but it won't break anything. But if you actually there's a whole list of what changes are compatible, which ones are not, which people should just
I think as long as you don't change the class name, your objects are just going to come out.
The solution that I think Jim Fulton came up with was a thing called generations. I think it was generations, which is just a mechanism that it's a extra interface you implement, and it automatically tracks the version of your object. So when you deserialize, it'll call the appropriate hook script to upgrade or to adjust the object, and it knows how to work its way right from the oldest version to the latest one. But it's something that happens occasionally, and it's going to it probably will throw you the first time you see it, because you're going to get very strange errors. That's going to take you a little while for you to figure out what's happening.
Yeah, and you always have the option of going back to a previous version of source code and running against that anyway, so you never lose anything.
But another great thing is you can run during the set ATR. You can actually run that in a persistent object, so you can actually. This is what generations basically or code evolution is basically doing. You basically find all your objects, run through them all, and say set ATR. Here's my missing attribute. Here's the default value.
So it just uses the standard.
So you can manually do that.
Pickle has hooks in it. So basically, your class can implement certain hook methods that it will call when it's getting and setting the state of the object. So at that point, you're given a dictionary of properties, and you can look at it and go, oh wait, it's missing this attribute, or this attribute's wrong. I'll fix that, and then pass it back, and your object's reconstituted then.
If I dynamically added some methods to the class, so I had, let's say, a lambda that I would put in as a method of some sorts, would that be pickled, or would I then have to take care manually of that, even if I didn't change the class, but if I did funny things like that?
I'm not too sure. I've never tried to do that with if you say self dot.
If you say
title is equal to lambda, so
I think
I don't know what's going to happen.
I mean, a lambda object is treated as an object, as a separate object, so it'll just get added on.
The thing is,
if you have a function and you follow
I think lambdas are pickleable. I'm going to say without ever having tested it.
Yeah, like we're all talking about pickling. Like pickle's the thing we use to store or serialize the data. Not everything's pickable. Like the tree, I think it was on the first slide. I had 3 things there where file object isn't pickable because it's an open file handle basically.
You don't want it to be either.
No. That's why you don't
function objects aren't pickable.
Function objects aren't.
Okay.
C extensions aren't.
So it's basically only data attributes really.
Pretty much any data.
To be honest, you can always test it by importing pickle and go pickle.dump.
Like if something isn't pickable, you're just going to get an error.
Okay.
You're not going to store something that isn't pickable. You're just going to get
it'll
error.
just fail. It won't. If there's anything it doesn't know how to handle, it'll fail.
Okay,
so
cool.
It won't do anything strange and corrupt your data.
No silent.
But a lot of people like through the web, Zope 2, which is like through the web application, and want to store certain funny scenarios for storing certain types of functions. So that's. That's adding. Next slide is persistent classes, and basically this is a handy function. Like for any object that you want to persist into the database, you should extend this class persistent, because basically if you change any attribute on this class, it will basically notify ZODB that this object has changed, and when you call transaction.commit, this object will just automatically get written to the file. So this is what basically makes modifying objects really simple to do, as we'll see. And the B-trees module contains basically similar classes for containers, and these are all dictionary-like, and OOB tree is for object-to-object keys. IO is like, they're all just efficient objects, so it's just optimized for integer to objects. You have OI and other efficiencies for using long keys and long values, etc. There's a whole bunch of them.
On those B-trees,
Sorry?
do you know if you modify an entry in the B-tree, does it save the entire B-tree again, or is it?
No,
just the bucket.
I'm not sure the entire implementation, but they they'll just save the bucket that the item's in.
It's one of the reasons you want to use it, because if you do use, say, dict or list or plain object and add that as an attribute and persist it, it will just save the entire thing, because the object isn't smart enough to just save the bits that are changed. But the other reason to use those B-trees is just because they're much faster and more memory efficient. So generally, it's only something you'd really care about, I think, in sort of the main container for all your objects. Usually you have one root container that contains everything, and then each object might have its own little list, but usually they're not very big, so you don't care too much at that point.
The format, if you're using a list, it copies it every time to the end of the file, isn't it? So if you read the list,
if you're not using one of the specialized classes, which are a bit smarter about persisting themselves, you'll get a lot of data churn.
Alright, so that's what the persistent and B-trees thing do. So I have a little example. Modified context. I'm just reusing some of the OpenDB connection. They're all the same from the original class. And here basically I'm just searching for all contacts with my name, and print out what I'm changing, and I'm just changing my name to my brother's. And then basically, since we're doing manual indexing, we have to index, so it's the search will just keep thinking of those objects have the original name. And then you commit, and the database is going to be saved with those changes. So all Michael Kerrin should be now. Thanks, Kerrin.
Do you have to explicitly call reindex?
If you want the index to be updated, yeah.
That's if you're using your own index, because
Okay.
ZODB doesn't give you one. I think
No, with all the indexes you have to re-index them, but if you're using an application like Zope has a whole event framework, so if you change something, you generally call object modified event, and then that will update the catalog. So the catalog will have code to listen for that and update itself.
Okay.
it can be very nice actually, because you can get very fine-grained control over what's happening in your application. So you
want to decide exactly where you want to reindex as well. So you might want to do a whole bunch of changes to reindex, so you don't.
You're very self-control over what you want. So it's really good for stuff like that.
Like for a bigger application, like we know in that application we're just changing the first name, so you could have an index that's just specialized for just changing the one index as well, and things like that. Or this search is just a simple one to basically show you that what we have in the database. And I think I just pass in Michael. You can see we should have two entries. Yeah, the first and the fourth one, because they ran the add contacts twice. So if we run Python modify contacts, changing the different word. and then we search for Michael, we didn't find anything. So we changed that to search for. Yeah, so we are persistent changes, so we didn't have to do any SQL updates or anything like that. That's modifying.
This collection search using ID attribute for searching?
Sorry? Yeah, no, I just had two for searching.
Which attribute are used by search if you want to search something from the...
I can search by first name and last name of this. So basically what I did was, each time you add something, I'd update...
in code you have collection search and Michael. So what was search? Which field or which attribute?
I'll show you the search contacts.
Yeah, exactly.
So basically, you just say search, passing in whatever arguments we're passing the command line, and then that calls in my contacts the search method. And basically it's saying get all the IDs for first name, get a set of all the IDs for last name, and them.
Okay.
And then that's it. Search. Okay, more. I think we covered this, yeah. So if you don't extend persistent and you add the object each time you modify the object, and you have to explicitly say this object is changed, and then the whole object is going to get written to data. And I think an example of that's simple. Okay, so we basically, first of all, we have to add simple unit on this one. Modify simple context. So basically, this is I'll just comment this bit out first.
It's Alt 3.
Control.
It's Apple S. Everything's an Apple.
Okay, so basically, this is doing the exact same thing as the previous modified contacts. I've just commented out that line because I'll show you what's going to happen without it. Modifies simple. Okay, changing. Yeah, so you're modifying simple contacts. Search for con. They shouldn't have changed any data because we were using a simple. We weren't extending the persistent class, so it never notified the thing that this object has changed. So basically, in order to tell the database that this object has changed, we have to know where this object is stored. So basically, in my application context, we had this data attribute which just contains a container of all the data, and basically we have to say data.p underscore changed is equal to 1, and just by setting this attribute, we're saying this object has changed, and then
I think to get that effect, you need two levels of objects that are not persistent, because the persistent object that contains it was smart enough to spot, I think, that the other one changed.
Yeah. No, see, the thing is, con here, since I added through the simple context, doesn't extend.
Can you show the add simple context script?
Add simple, yeah. So basically, you're adding a simple contact, and this differs from the contact in the fact that it doesn't extend the persistent. Everything else is the same.
Oh, I remember, yeah.
Yeah, so the first one was simple contact, that's what we just added. So it's not persistent, it doesn't extend persistent, but this guy does. So like the still gets stored, no problem, your data's still there, and if you change it with the setting the underscore change to 0 to 1, like your data's still going to be changed, but you're just going to have, in the database there's 2 objects. And like if you keep adding objects, the database is just going to grow and grow. If you keep modifying this object, the database is just going to grow and grow until there's a mechanism, like an administration mechanism called hacking, where it basically says takes the last live object and then all the other ones it just deletes, and then your database just shrinks. So a lot of databases have some administration function.
It's the database object is a transactional object. It's not actually, to make it more robust, it just appends each transaction at the end, and so you actually have multiple versions of your object stretching back to all your transaction commits, and that makes it very nice because you can just literally pull the plug in the machine, and it will never get corrupted up until possibly the last transaction, which might have gotten written properly. So that makes it very robust and very good from a application point of view. The only drawback is because it's an append operation and it never goes back and overwrites anything previous, your database can grow quite fast, especially if you're persisting more than you think you are. You've got some attribute which contains a 10 megabyte blob or something that you don't realise that you're doing it that way, and it'll grow very fast. So there's a process called packing where it'll spool through the transaction log and only store the latest ones or last week's worth of transactions or something like that, and then that will pack it back down again. So that's usually that's an advantage of using ZO, which is the client-server version, because you can pack the ZO server without actually taking down your application server, because the application server will have cache.
You can keep
yeah.
The packing works live, so
it depends how it's done. Sometimes you can't.
Zope, all you do is you click on a button and just.
Yes, because it's calling the pack method. But if you want to pack it, if you have multiple clients, the nice thing about ZO is that if you have multiple clients, they can keep operating off it without.
Yeah, you're going to have to. It's going to have to be off in a thread or a different process. So if you use the process, it has to be ZO. So set ATR and get ATR, yeah, can improve the. You can just. An persistent object you can get is set an attribute. The attribute will get stored. Over that before, I think there's. I don't know how much time I've done this for. Blobs, this is probably 3 weeks old now. It was just added to version 3.8, that's why they wanted version 3.8. And so, which now the version was never released like 2 or 3 weeks ago. Basically, since we're storing all these pickles, if you have a big PDF document or just a big blob of data and you want to write it, basically you're going to store it as store this data as an attribute to an object and then serialize that. So there's a huge inefficiency in doing this. And so basically what some guy from Germany did, he basically said, right, provide a mechanism to create a blob object. You can just open the blob object, write the data, and it will be written to a file. And this all works within the transaction. So if the transaction aborts, none of your data gets, none of the data is stored or modified.
It's done cleanly.
Done clean, yeah.
Are blobs stored in file system?
Stored in a file system. I have an example of it. So basically, remember before when we did the file storage contains all the pickles, so we still need that, but we also need a storage for all these blob or files. So this is blob storage. Blob is the actual object that knows about these files and is integrated with the transaction mechanism. So basically, exact same as before. But this time we create a blob storage for all these files, and this is a directory. And basically we're just saying, here's the base storage for all the pickles, and this basically has the same API. A blob storage has the same API as a file storage, plus the store, I can't remember if they are store blob, tree blob or something like that. database exact same.
So ideally, you don't really need the file storage anymore. You can
You
just
do.
You do.
Yeah, because you still need to store the pickles. So the pickles are still going to be stored in the data.fs or was it blobs.fs. So in this case, the blob is still a Python object, and still it doesn't make sense just for small files or small bits of data to store it in its own file. So this guy's a Python object, so when you open it, you get back. It's basically a file handle, but it's wrapped. So basically, if you write to it, it tells the database it's changed, and basically the database will keep track of all of them. So when you commit all of them, any ones that are still open will get closed and things like this.
What's the reason for blobs? Is it for scalability?
Yeah. So if you have like we do a lot of document systems, we document basically a system. Even like PDFs, which can be like 100K, whatever, and basically each time you're storing these through the standard way, through pickles, you're basically pickling all the data that's in the string, and that just takes time. But if you just write it to basically a file, and then on close basically saying this file handle is not needed, we have to store it in the database. So basically in here we're saying update, or in SQL this would be like update some column setting the value, and then on transaction.commit, the file that we wrote, which is just this file, is going to get written into this directory, and basically next time you can open this, modify it, and if it commits, the data will be still there. And it does the same thing, so it doesn't delete files. Like if you modify this, it won't delete the old one, it'll just leave it there, and then just create a new file on the transaction ID, and it keeps just getting bigger and bigger. So basically then you have to do is pack the database, and it will find all these old files and delete them. So
it's kind of useful again for the transaction churn. Like if if there's a lot of edits being done to a 10 megabyte PDF, you'll get that with the older file storage. That'll get added on each time, so your file storage grows very fast. Whereas with the blob mechanism, it gives you a way of managing it separately. Because traditionally, the way you'd have to do it is you'd have to write your own set of code to manage files separately from your objects and make sure they're written out, and then update everything. So whereas this will store all the transactions and keep it all nice and synced.
So we'll just basically, this app blob is just going to write the app blob file into the database. Guess
it wasn't new enough. I guess it's a bit too old.
You did install it.
And import ZODB, it's double underscored file. Maybe I've got a different version from somewhere else.
That's what I was thinking of doing.
321. Oh, I got a Zope install and it's overwritten the Python path. We'll fix that. I blame Zope.
Nobody else is eating the chocolate. We're there for you. It'll only go off, I don't know.
So the first time we ran that, so our Vargert, we have blobs, which was the different storage. I just used different storage there. Then we have blobs directory. So if you look in there, blobs. This is the 01 is actually the transaction ID for this. So and then stuck in that file, and it's just the file we just ran. And so I think I'll go with reading this. Yeah. So basically, if we run, in order to get this data out again, exact same as before, get the data out of the database, or get the blob out of the database, print root keys just to make sure we just have the one, and basically open the blob, get a file handle, and just read it and print it out. That's the data. And so if I rerun this add blob, which is going to add the same data, the thing is, and that's smart to realize, I'm adding the same data, but if I rerun it, and this blobs, you see we now have two directories, and in the first one, that was the original file, and then this is the one we just overrated, so there's where the data is, and that's blobs. That's all there is to it, but it's just, especially for some applications, just going to make that has big data, just make things a bit more efficient, I think.
Actually, can you, from the Python interface, can you actually get the file name of the blob directly?
Good.
So you could pass that to some external application, so it could just read the files directly. Apple's out. It's coding in a different OS, machine, a different editor, in front of an audience.
Keyboard.
The US keyboard.
And touchpad.
How do you add a hash? Alt 3.
Alt 3?
Yeah.
There we go. So it's Apple apart from that.
Yeah. Apple to do stuff. Or also option as it's known for certain things.
Okay, so just from my side, it just imports the file for me and runs it. So we should have DB object. Yeah. So just did that so I don't have to type up all the stuff up the top. So, thanks. So in the Python interpreter, we have all these variables to our disposal. So we want to get the blob is equal to root plus blob. Yeah. There's our blob object. So just do the URL blob. Looking at this is probably something I should have mentioned earlier. Remember when we did p underscore changed? That was a special kind of variable. You can't set a variable name with underscore p underscore, and the same with underscore v. V and p are they're two special names. So when the database is trying to find all the attributes, if it begins with this, it's just going to ignore the things or the mean special things, and strange things could happen.
Is the underscore p is reserved for use by ZODB for persisting?
Yeah.
Underscore v is
volatile.
when you want to say a volatile attribute, don't store this basically.
Yeah. So basically,
so
for caching, you could set an attribute as underscore v, and then it just won't get written, but you don't have to recalculate stuff.
Good question. Is ZODB keeping using Python Unicode objects for storing all strings, or
No, it's up to you.
Standard-based.
It's up to you.
Yeah.
If you set the attribute to a Unicode string, it is stored as a Unicode string. If you set it to an ordinary string,
So
it is stored as...
I can sort using rules of any language if I am using Unicode objects.
You could, sorry?
If I'm using Unicode objects, I can have information about collations, so I can sort according to any rules according to language. I can sort with Greek rules, with French rules.
Okay.
It's just working on the object level. The ZODB is not even aware that you've got a Unicode string. It just sees an object using the pickle mechanism. So it's one of the nice things about it is that any issues of encoding and getting databases just don't happen.
Yeah, but if you are searching for text,
It's
and
the same rules that
you want
apply.
to treat lower uppercase character the same, and if you are using characters which are outside ASCII
It's the
code,
same rules as normal Python Unicode. So anything you have to do in Python to do string collation and handle structure properly, you have to do it the same way.
The same comparison.
Yeah.
It's just the objects you're using
Yeah.
weren't created during this instance of the program. It could have been created last week or the week before. That's the only thing.
It's purely a persistence mechanism. It does nothing. I mean, again, it doesn't have an index or anything. So it's just you have to
It's
do
just
your own.
storage. It's just interesting. It's best way of storing the data.
It's like extension to normal Python.
Huh?
It's like natural extension to normal Python.
Yeah.
Yes, it's programming centric.
Yeah.
Data is
Yeah.
database centric.
I think
Yeah, so that-
Jim Fulton wrote it, didn't he, in a week?
Yeah.
No, he wrote it as sort of initially they wrote just a thing about pickles, and then a week later he wrote this mechanism, and that's pretty much how ZODB got written. It sort of just happened.
Yeah, alright, you're just following.
So that could, for me, that would be very, very useful.
think this will have to get included in the standard Python library.
No, it's always going to be an add-on. I think it's like the standard Python library because there's endless number of persistent layers. So if you want to store ZODB, you might as well then start including the object relation mappers, and then in order to use the object relation mappers, you need a. Well, I suppose you do have SQLite.
Yeah, I mean they're generally a little bit cagey about adding stuff to the standard library. They very much don't want to bless any one particular mechanism over another. So that's why they've. I mean, it's taken years for like a new XML library, elementary, to get added on, purely because it was just really nice and everyone liked it. So
and not everyone uses ZODB, but it's just I think Bert no like.
What about adding a persistent object mechanism?
Well, there is Pickle, which is built into
Yeah,
Python.
so
And
you can see it.
I've written. I mean, the app before we used ZODB, we had our own little mechanism written using Pickle.
But you could
100 lines of code, isn't it?
I mean, most of the background work is done by Pickle in this case. You're leveraging what's there, really.
I think the smarts of ZODB really come into the transactions. That's where it gets quite nice because you can have multiple connections to your database, as you were talking about, and each one is independent. So you have different blocks of code and different threads or
They
whatever.
don't have to be a ZODB, but one thing we're using for one of our projects is we're using Zope, so you have a ZODB, but we were also using a Postgres. And so basically what we need to do is when the transaction commits, both of them are committed, and if one of them fails, you want the whole lot to fail. So basically it's very easy to, using the transaction module, which could be basically another talk, to add different resources which are the two different databases and keep track of both of them. There's no limit to just who you could keep adding resources to say like all these databases. It could be ZODB, it could be any number of relational databases. I think that's pretty much it. I said there is, I think this is fun. Yeah, lists are worth mentioning because standard lists, like so if we have an object with just our context has an alias, and basically this is like the when you like if we edited the first name, it automatically gets stored, but if we append to a list, this thing won't get stored unless we set this, because this could be to search. basically in a list there's nothing to tell you that it's been modified. You can always tell if it's been like set. So if you said Michael.aliases is equal to a list, that would be set because the attribute on this object changed. But since we're just appending to the list, the persistent object ZODB knows nothing about this. So if we didn't do this, this never works. So
I mean, the other way of doing that, which I've also seen, is you just simply do aliases equals Michael's.aliases, aliases me equals something, and then Michael.aliases equals aliases. You set it back in, which calls the set after hook, which triggers the persistent.
There's another way of doing it. Doing the persistent.persistent, there's a persistent.persistent list,
which
will automatically notify. But it's rarely used, I think, in order to tell, like if you're appending to a list, I think there is a performance penalty in actually checking for all this, so it's actually really rarely used.
That won't be specific to the list and only any reference you have,
yeah,
which
any reference.
Changing the reference in place instead of,
basically that object either has to inherit from persistent or you have to give a nudge to let it know. Because the hooks in ZODB are only on the getting and setting of attributes.
Yes, so we have to set it on the root object, add it to the root dictionary, and then any attributes on this object is going to get stored. And then if there's a persistent object, then like it's kind of like if you can reach an object, you get stored on transaction.commit.
I mean,
and if the database knows a change.
It's kind of I think in a way it's just to keep a sane performance trade-off, because ZODB could wrap everything with a layer which checks for changes, but that would just destroy your performance. So it's just kind of a level of sanity, really.
One thing just generally is I'm most of the time actually fiddling around with searching and finding my objects. That where, at least in my use cases, lies most of the problems and intelligence in the software. Now, from your experience, if you take a pure ZOPDB, I mean, even though you showed us how to create a simple index, if I then I have a look at the Zope world where you have stuff like text index, NGE3 and stuff. From your experience, how easy would it be to integrate such things, or how do you go about it?
To an extent, it depends on your application. I think in my case, for the stuff I do, it's a predominantly tree hierarchy of data, and then I have a few secondary indexes which are actually stored in each object, and they'll keep references to other objects by ID. So I actually keep the indexes on a per object basis, so that when I chuck out an object, the index relevant to that object goes with it, and I don't have to worry about it. But I think I've never used text index NG or any of those outside of Zope. That's very much a specialised one that actually is for full text indexing, so it's kind of a... But
there are tons of indexes, and lazy me wouldn't like to re-implement things like that. And from your experience, is it possible to just reuse them?
Yeah.
Or
it is possible.
But I think
those two ones are very tied up in the application.
You can't use the Zope 2 ones outside of Zope 2.
Not in the same.
Yeah. But I think the approach of just keeping an external database for key metadata works very well, because
using the transaction module.
Because the nice thing about it is that because you're only doing a little bit of indexing for a light amount of use of SQL, it generally never gets very complicated. So you can use another one, the object mapper layers, and that works fairly well. But it's kind of, I think when you're doing ZODB, it sort of, if you just use it as a direct substitute for a SQL database and approach it as a relational system, you're going to be quite upset with it. You're not going to have much joy with it. But the problem of indexes, I think, is something that ZODB doesn't give you. It doesn't give you an index because that's not what it does.
It's just about storage.
So it's very much kind of goes, well, it's application specific. Here's a few third-party ones, but most people tend to either roll their own or use a SQL database. But the nice thing with Zope 3, I think the index, the catalog stuff it's getting to a state where you can just use it in an app.
The difference between Zope 3, they have very defined, for each module, pretty much very well defined, so you don't have kind of creep of stuff leaking into other projects.
Because I did try to use Catalogger once outside of Zope, and I wound up running Zope inside my app. Because it just needed everything, so it's kind of...
I mean, if you're saying, if I may continue with the question, okay, just index your objects in a relational database, might it be Postgres or MySQL. I mean, why not store your objects there? I mean, I find the beauty of the object database, the flexibility. As soon as I enter the SQL word, all flexibility in my experience is gone.
Yeah, I mean, it's something really you're only doing as a kind of, the last phase of your project, performance optimization, where you seriously consider using an external index. If you've got a serious performance bottleneck that, it's either re-architect everything and start from scratch or add an external index.
But the role of arguments, I mean, the initial question was, how do you find your objects? So before performance came in, I mean, that's a normal question. A normal situation, you said, okay, you store them in the SQL database. Now, following from that, I was wondering, well, if you're using the SQL database anyhow to index them, then you could just as well hop over to there. And
you
why
could
not
do, but then
you,
I mean, as I say, you lose the flexibility, but you also, I mean, the thing about ZODB is that if you're spooling through, I mean, if your app is, say, walking through a tree of if you're navigating through a tree of objects, you are probably always going to beat the performance of SQL database because you don't have that serialization layer to go through. But I mean, the thing is that one way to think about indexing is that, I mean, we treat it largely as how would you write an index for an pure in-memory Python application, well, a dictionary, and just persist that, and that works just fine.
That's what I did.
And it's really, that's all. I mean, for the stuff I do, it's all we ever need to do. We have a couple of sets. We have a dictionary.
But another thing is like flexibility. I don't know if you went into too much.
I think using ZODB, you have to think in different ways.
Yeah.
Because you are working with multidimensional data, not tables. It's similar to Excel line and PostgreSQL data, which I discovered recently that it's built and stuff, but it's more transparent, of course. So access to nested objects may be very fast because you can go directly for reference instead of searching for index. So
it's you really notice it then.
You need to think in different ways.
Because I mean, what I do with my objects is basically every object has a ID, which is just it's the ID whenever a user goes, oh, I'm messing with this thing here. It's ID blah. It's just it's how people can just type in the ID into the app and it will zip straight to that object in the tree. And what we do is we have a couple of indexes for things like it's kind of hard to describe without describing what the app is, which is an internal one. Basically, if you can imagine it's a tree of insurance portfolios, which then we run models on to get various different analysis on. And so for, say, each model object, which is just a name and then a few bit of metadata telling it which model stuff to invoke, it also has a list of all objects created using that model. So when we go, oh, what objects have been created using this model, we just spool through that list straight away. And then we just have a series of events and hooks that when we modify an object, they listen, they update the various different references around the place. And that works really well. And the nice thing is that generally, in most cases, you've actually got, the indexes get loaded into memory pretty much straight away when you're trying to start navigating, and they're just there in memory as a Python list. And so you get some very good speed on it. And the app, as I was saying, has I think it's up to 400,000 or 500,000 of these objects, and they have all various different sizes of data. And the ZODB file data.fs, so that's the pickled version of the objects, which are usually smaller than what they'll sit in memory, is 1 gigabyte, but the app typically only runs at about 200 or 300 megabytes of memory usage. So, and even though it's got all these indexes in memory, that's Python lists and objects, so it's, on balance, it works pretty well, and you just have to think a little bit differently. So it's, we haven't had to resort to an external SQL database, but we're probably going to have to keep the SQL junkies in our company happy, because they don't want to connect to an object database and do stuff, they just want to do SQL queries. So we're probably going to pull a whole load of metadata, dump it in a SQL database, just so they can construct a query to get the ID of the object that can ask our app to get some data out.
It's the comfort of the query.
So that's the other flip side, is that if you're in a company where everyone is just SQL gurus, it probably is insanity just to do ZODB database, because you're just going to upset everyone else and they can't use it.
So they won't be able to use it in
tools
and
So there's a balance to it. I mean, but the thing is, for an embedded database and an application, a desktop one or something, it's really is the business. So I'll show you.
I think I'm nearly finished anyway. Yes. Yeah, so I think we've covered this. Like, the only other things I won't cover now are like the ZO, which is basic client server. You have, remember when we open up the data.fs, that sits on a server. You have your ZO server, and then you can have multiple ZO clients and multiple processes and multiple machines just connecting to it. It's like how Postgres works out of the box and MySQL out of the box.
We actually use it across a high latency link across the Atlantic, and it's one of the things about ZO is that it's a thing called a ZO cache you can have, which it's kind of like a.
It's pretty much the data.fs.
It's a copy of the data.fs that gets built up in your local disk, so it's kind of like once the local copy of ZO client is happy that its copy of the data is up to date, it'll just get stuff out of the local data, so you can operate fairly comfortably across a high latency link if you've got most of the data at some point. So.
And blobs work across ZOs as well, but probably not too much sufficient. Transactions, which are interesting, like we talked about before with the local databases, and there are save points, but I can't remember exactly what they are, so let's skip that.
It's if you need to. One of the things about the transactions is ZODB uses an optimistic locking mechanism.
Yeah.
So instead of having to lock the rows of a database when you're changing them, which some databases force you to do, or lock the objects when you're changing them, that some object database force you to do, you just grab the objects, change them, and then try to commit. And at that point, ZODB might go no, sorry, someone's changed it in the meantime.
So you get conflict there.
So you get a conflict there. So the idea is you have to retry your logic then. So the idea of the save points is that you can have incremental commits, and you can, as you go, you'll see how you're going, and then you can roll back to those points as things go wrong or whatever. So it's just to speed up, because I've had there's one operation we do which is deleting a tree of objects, which potentially can take a while to build up a tree of finding all the various bits and pieces you want. And the problem is, of course, since this operation takes quite a long time, there's a very good chance that someone comes in the meantime and edits something and gets a bit frustrating. So the way I work is, the way Zope does it, and the way my app does it, it just retries the transaction a few times. Like it retries the whole operation, which can be slow, but it will get there because the 2 or 3 times is usually the most you've ever gone. But if you're basically finding that if you say set a retry count of 10 and you're hitting that, you probably have some a kind of hotspot of data somewhere, whereas a lot of things touching that, and you need to basically there's some useful objects that the Zope folks have written that let you do very simple. There's a very good queue object which lets you do a queue that can be shared across multiple apps.
And it doesn't conflict.
And it doesn't conflict, which is...
just add things to the end, and just, if it does conflict, you just go, stick it at the end of it.
And then the conflict count just goes to almost 0 with that object. So
and there's a way of doing, if you have certain types of objects, there is ways of, if you do get a conflict, there's a way of setting a method on your persistent object that will get called with the old state and the new state. And so if you can manually pick which one you want or which data should be stored.
That's all a bit screwed up.
I'm sure I've never managed to get it to work, but it's there.
I used to use it, but the MVCC screwed it all up. The MVCC prints 2 different versions of the object. So the resolver...
Are they getting rid of MVCC after all that?
They sure it's rubbish. but the resolver can't resolve them because it's on 2 different objects now. It used to be the resolver was on 1 object.
Well, I think they're chucking the MVCC because it doesn't work, which means hopefully the resolver will work again. In practice, it generally doesn't happen as often as you think, because if you've got enough users and a big enough set of objects, it's not, typically you don't get 20 people editing the same document at the same time independently. So
I've run into a lot of problems around Zope. on things about data directory.
Yeah.
So, and the directories get using the bulk jobs.
Just a small question with if you're using a ZO server and you've clients, can you have two clients sharing the one object? So that if one client updates the object, does the other client automatically
get the updated
version, or
it gets
do you have to put in a manual?
It gets notified of the change and it can pull the object if it wishes to.
Yeah, like the transaction always happens at the storage, so it'll happen on the server. So let's say if you have process A raise the object, raise the object, process B raise the object, both of them, process B finishes with it, this guy writes, this server will actually notify this client that this object changed. So the next time he references it, it will actually go back to will skip the cache, go back to the server, get you the new.
And ZO is part of Zope again, but
it's part of ZODB, so it's completely separate. So when you do the easy install on that URL, it downloads ZODB, or it's ZO.
But no, it applies the same transaction rules as just using the file storage. That if you have two connections, one modifies the object, the other one is unaware of that until it goes to commit. It's the optimistic blocking again.
Yeah, a bit like version control systems. As well.
Basically, it's less annoying to do optimistically rather than go kick over the other transaction halfway through because the object's changed under its feet. So it's kind of generally it works more often than not doing it this way. Because there are some object databases that you do have to explicitly lock the object if you intend to change it, which is incredibly annoying, and generally that's what gives object databases a very bad reputation amongst a lot of people.
There's just one last thing.
Should have turned off the screensaver.
With the ZODB, you can have multiple storages or different storages. So one of the most common, apart from the file storage, which is probably the most common, the other one is demo storage, which it doesn't actually store the data, but it's great for testing. So you can write tests against it. All the tests in Zope use the demo storage because it doesn't store the data, it's all in memory, but you still have all the transactions working.
It's dictionary, isn't it?
Pretty much. So, and then there's Postgres storage, so basically instead of using a file, you write all your pickles to.
That is the most pointless storage though, because it doesn't do what you think it might do. It doesn't sort of construct a table based on your objects.
No,
it just stores a blog.
It just stores an index of the object ID in the blog. So I think it was literally created for people who go, I will not let you ship a product unless you have SQL support. Okay,
right, you got it.
So I pity anyone who tries to actually read the SQL database and make sense of any of that.
And there's been others that people have tried in the past, Berkeley storage as well.
I think the file storage is pretty robust.
File storage is the best fast.
Yeah. The only thing downside of the file storage is because it's a append only writes, it can get very big, which is where blobs really become useful because
it doesn't get it.
For example, in my app, there's.
But you still have to pack because you're still creating new files because there's no way of doing each time you had to do a compare each time you
made it. Are tuned for small files.
Yeah. Because one of the problems it used to have in some OS is that when you hit 2 gigabyte for example DataFS, the OS would hit its large file limit.
Once you get 32,000 directly.
Well, 250,000 entries in a directory generally kill most file systems. I'm not speaking from experience.
There was APE, wasn't there? By I think heavenwellmix.org, APE.
Oh, APE, yeah.
APE.
That's more a Zope specific thing, isn't it?
That's my question. Is that ZODB or is it Zope?
I think it's Zope because what it does is it translates the Zope objects.
Discontinued.
Yeah.
Most of these things are
directory storage, source storage.
Yeah, that one. The drawback with these is that they can't match the performance of the file storage.
There's another one, directory storage, where you have pick one file per pickle.
Yeah.
But
again, that's used mostly. I think the main people someone would use that is that for it tends to they can scale it across their spindles slightly different. They can do a bit more control of the way it scales across, and it's easy. I think that they've hot shots or you can do live snapshots of it. You can do that with DataFS anyway, if you don't mind risking the last transaction.
Big thing for me in terms of keeping it outside, I use Zope and use 8 at the moment. I'm not directly stored. It's just getting the CDS. All the objects are CDS.
I mean, again, that's kind of a Zope specific thing, because what it's doing is it's translating your, like say the Python scripts and your pages into actual files that are just like blah.html and blah.py. So as you can suck it into Subversion or CVS and version control, and it's very, very nice. But that's I think it's pretty much a Zope specific, because you have to tell it that this is a HTML page, and this is a.
Does that also work the other way around, that you can basically learn? I mean, you have your stuff in Zope.
Yeah, there's a.
And basically use then SVN to.
Yeah, there's.
Have a.
What's it called? I've used it
through the web development kind of. But that's going too deep into Zope probably.
I think it's a local folder object. I can't remember. I've used it in the past year where I've created all the stuff in, as file system edited that way, and there's an object you can do that acts like a Zope folder that just reads it off the file system.
File system directory view.
We use 5 or the Zope 3 use it also in one of our user persistence. You don't have the issue of you just like version control your source code files.
Yeah, I mean the solution to that in Zope 3 is you don't have through the web editing. It's all you do it all.
There's loads of edge cases to go ahead editing that validate in this year. Should be right now. I think that's me. Unless anyone else has something else to.
That's great.
That's great, thanks.